Hey, let's go. Let's learn how to do substitution. In this, we're just working with slope-intercept form 2, something we're really comfortable with. Let's do this thing. How can substitution... Now, this is not in your note packet, so I dug this out because I needed something different to kind of organize us with this. How can substitution help you solve a system of equations? Okay, a couple things we need to remember and kind of note as about what we're doing here. So what is substitution? I'm going to kind of divide this into two parts here, one slightly bigger than the other. So when I talk about substitution, what we're talking about is replacing a variable, right? What are we going to put in that spot for that variable? Well, there's three things we could put in there. We could put in just a plain old number, or we could put in a variable term. So that would be like 2x. Or the third thing here is we could put a whole expression in there. So let me make a little side note here about this. So if we put a number in, it could be 2. If we put a variable term in, it could be 2x. If we put an expression, it could be 2x plus 9. Like all of those are things that we could put in for a variable. What we're talking about specifically then would be, or as an example, would be like x equals 4, and then you have the equation in slope-intercept form y equals 2x plus 1. So all we're going to do is take this 4, put it in for x. Yoink. There we go. Y equals 2 times 4 plus 1. Y equals 8 plus 1. Y equals 9. So that was substitution that got us to a solution for y. What do we know so far? Well, what we do know is we do know how to graph. And just as an example, so the actual lines that I draw here won't make a difference, but just a reminder here. We do know how to graph, like there is a line, there is a line, and we remember what we're doing with this is that wherever those two lines intersect, right there, that intersection, that intersection is the solution. That's the solution for that system of equations. Now, I'm going to turn let's see if I turn the light off. Oh, that's a little better with the light off. Let's do that. When we're solving with substitution now, we're going to do the exact same thing as graphing, except we're going to do everything with math. Right? This is all going to be about finding this spot where the two lines intersect solely with a calculation. Right? That way we're not graphing at all. We can do this completely abstractly and have it be completely driven just by math. So some notes about solving with substitution. First is we have to solve for both x and y. So we're going to do two separate equations that work with two different equations. When we do that, when we solve for both x and y, we have to solve them one at a time. Right? We're going to solve for y and then get x, or we're going to solve for solve for x and then get y, or solve for y and then get x. Lastly is, just like kind of a reminder here, your organization is so important here. Be able to read what you wrote. Keep track of where you are on your paper. Know what you're doing so that when you do this, you can go back and see what you've done and then be able to derive a solution for what you have. Let's try this one. So we're going to do this, right? We're going to take an equivalent for y, substitute it in, solve for x, take that value we got for x, substitute it in, solve for y, and then write as an ordered pair. But let's look at how that works. Something to remember. These y's and these x's are the same. Both those y's are the same to each other. Both those x's are the same to each other. These are two lines that are working together. We don't draw this bracket, but that bracket would tell us that that is a system of equations. Then, if I know that this y and this y are equal to each other, if they're the same, Then what I can do is I can take this expression, which is equal to y, and substitute it in for the other y, right? Because these are the same. If y equals this y equals that. Now what may seem weird is that if this y is equal to 5x plus 12, that means this y is also equal to 2x minus 3. But let's not get too off the deep end here. So I put a little circle around this and then drew an arrow to the y to say, that's exactly where I'm going to put this. And then I'm just going to write what I've got. I put this where the y was and then wrote the equation. Now we're back to first semester. So in first semester, we solve problems like this. We've got two variable terms. Let's eliminate one of those variable terms. I would suggest we get rid of the 2x from both sides. When we do that, we end up with negative 3 over here. But on this side, we're left with a positive x, and that's why I chose to do that. I could go the other way, but it's easier to do it this way. At least for me. For my brain, it helps that. Now I've got a two-step equation. When I do this two-step equation, I'm going to subtract 12 from both sides. That leaves me just 3x here. Like, don't forget, like when we choose these values, that becomes 0, that becomes 0. Negative 3 and negative 12 together will give us negative 15. We're down to just taking care of this coefficient. Divide by 3, and we get x equals negative 5. That's fantastic. Guess how much we finished? Half. We're only half done. Don't forget, we've got to solve for both x and for y. So what we're going to do is we're going to take our solution here, and we're going to substitute the x back into one of these equations. Now we get to choose. It should come out to the same thing for both. So I'm going to write 2x, that's wrong, y equals 2x minus 3. Boy, my arrow's off now. I'm just writing this over here. I'm going to take my negative 5, which is equal to x, and plug it in right into that spot. I hope that's not confusing. So I just drew this arrow to say I'm bringing this equation over here and writing it here. And I drew this arrow to say I'm bringing the equivalent of x to where x is in the equation. So when I write this, I've got y equals 2 times x. But in this case, I'm writing negative 5 minus 3. Y equals negative 10 minus 3. Y equals, well, I've got 10 negatives and 3 negatives, which gives me 13 negatives. We've solved for y. Now, finally, I've got to write this as an ordered pair. Now, don't forget, it is x and y. So I go and look. Y is negative 13. That's got to go right there. Yoink. X is negative 5. It has to go in that first spot. Right? And that's the solution for this. What we know about this, these are the only two numbers that I could put in for x and y over here and make those equations true. All right, flip it over. Let's do one more example. Now this one, yeah, let's do one more example. Example 2, I'll do this slightly different than I did in class. And we'll do y equals 2x plus 3. Oh, my phone's ringing. I'll get it in a minute, don't worry. I'll do y equals 2x plus 32. And then y equals 10x. Well, that's kind of exciting. Okay, so I only put one term here. Let's see what happens. We got to take one of these expressions and put it into the other equation. So for this, I'm just going to take this one. I'm going to put it right there. So I'm going to rewrite that as 10x equals 2x plus 32. That's pretty straightforward. Now we're just solving. I've got two terms on this side, one term on this side. I know I want to end up with one on each side. So when, holy cow. Now my son is calling. Oh boy, something's going down. I got to finish this. Let's finish this. So I'm going to take 2x from both sides. Now I'm doing that because this 32 is not a like term with the 10x. That leaves me 8x equals 32. Now we're back to a one step that we learned how to do in 6th grade. and I get x equals 4. Now for that 4, I'm going to put it into one of these two equations. We can choose whichever one we want. I'm going to use y equals 10x. See how I did that? I lined it up so it met the arrow. Y equals 10. Now let's put our 4 in, times 4. Y equals 40. So now we have an ordered pair where x is 4 and y is 40. All right, that's the basics of it. Day 2, we can make it a little more complicated, but that's great. Good luck. If you have questions, come and find me. It's okay. Wait, now I hit the wrong button here. Hold on. I got to hit this button.